Okay, so this is a chapter 3 review assignment. So let's take a look at number 1. So the median house price in Red Deer, Alberta is $319,100. Okay, what's another, what is the median, what does that mean? There's 3 measures of central tendency in this chapter, right? Mean, median, and mode. Do you remember what the median is?
The middle number.
The middle number, right. When you, no, not the average. The mean is the average. The median is the middle number when you arrange them from left to right. Okay? So the median house price is this right here. What does this tell you about the housing market?
Wait, so why in the book does it say median is the average or mean of 2 middle numbers?
Okay, so if there's, okay, the only way that average comes into play with median is if you have, like let's say you have an even number of numbers, there's no middle number here, right? There's no middle number. So then the median would be the average of these 2 numbers beside. So the median is 2.5, it's right in between. So this would be the median, but the average of all the numbers is the mean. So if there's an odd number of numbers, like 1, 2, 3, 4, and then 5, if there's an odd number of numbers, then this is the median, right? That number is the median. But if there's an even number of numbers, then you do have to average the middle 2, or you have to take the, yeah. Okay? That's where you could be confusing average and median.
Okay.
That makes sense now?
Yeah.
Okay, good. Okay, what does this tell you about the housing market? Let's see, half the homes in Red Deer cost more than $319,100, half cost less. Okay, that's a pretty strong candidate there, right? Because if we list all the house prices, the median is the middle number, so there should be half the list before and roughly half the list after, right? Well, what about this? The average house price in Red Deer. Oh, the median is not the same as the average price, right? So we'll cross that one off. This is the most common house price. That's not median, that is the one that appears most often in the list. Mode, right, so it's not this one. And none of the above, no, I think A is going to be your correct choice. Okay. All right, which of the following data sets has a median of 30? Well, these don't look to be ordered in order from smallest to greatest, or from greatest to smallest. They're not in order. So we kind of have to be careful with this one. How many numbers are there? 1, 2, 3, 4, 5, 6, 7. So the median of 30, if they were arranged from smallest to largest, the very middle number in the list should be 30. That's what we're looking for, okay? So what I'm gonna do is I'm going to take the first list and I'm gonna write them on the side in order from smallest to greatest. So the smallest one looks to be 20. Then 23, then 34, then 38. Okay, now there's 7, so I only have to look at the 4th one. Okay? The 4th one. This is the 4th one. It doesn't matter about the rest. So is that 30? No. 30 isn't even one in here, right? And it's an odd number of numbers, so there should be a middle number, so not A. Okay, that's A, so not A. B. So B, well, we have 30 in the list, that's good, but let's see, the smallest is 20, then we've got 24, then the next one is 29. What's the next one after that? Ooh, 30. So is there, how many are there? 1, 2, 3, 4, 5, 6, 7. This is the 4th one, look at that. It looks like B might be the right one here. Let's just check the other ones. Here, 20, and then 28, that's 2, 3, oh, no, 3, 4. So 31 here is the median, so that's no good. And then D, let's see, 21, 2, 3, and then the 4th one is 26, looks like, so it's not that one. So it's B. Does that make sense?
Yeah.
Okay. Very good. Okay, the mode. Now the mode's pretty easy. It should be. It's the one that shows up the most, right? So I see that I have a lot of 5s. 1, 2, 3, 4 5s. Okay. Are there any other numbers that are repeated? Looks like 13. So 1, 2, 3. 6 is repeated. 1, 2, 3. And 14s are repeated, but that's only 1, 2. Okay. So it looks like, is 5 the mode? Does it show up more than all the rest of them do? I think so. Okay. Okay, I'll let you do 4 on your own. Let's do 5 together because this is an average, a mean one, okay? It's a mean one. You're a mean one, Mr. Grinch. All right, so the mean is the average, right? Average. So I want to add up all of the daily temperatures. So that's going to be 0. Well, that's weird. Is that a -0? Okay, that's weird. Usually you don't have to put a plus or a minus on 0. 0 is just 0. So I don't know if that's a typo or what. Those are 2 zeros. And then we have 0.1. So we add up all of these numbers here. And then I divide by 1, 2, 3, 4, 5, 6, 7. Then I divide by 7, right? So we're going to add them all up. And then divide by 7. So we'll get our calculator out. Let's try that. Okay, so the first two are zeros. So 0 plus 0. Then I have plus 0.1. Plus, oh, this is a -1. So that you could do -1. And then -2, because you're adding a -2. And then plus 0.3 and plus 5. Okay, so does that look like the right list? 0, 0, plus 0.1, -1, -2, plus 0.3, plus 5. Okay, so if we add up all those, we get 2.4, which is not the median because we have to divide by the number of numbers. So let's see, is there one that says 0.34?
Sí.
Ah, sí.
Yeah.
Sí, señor. 34. So 0.34 degrees Celsius, okay? How's that? Is that understandable? Easy? Got that one? Okay. Another median question. I'll let you do that one. Median, that's, oh, trimmed mean. Let's do a trimmed mean. We haven't done a trimmed mean one. Let's skip to number 8. Okay, trimmed mean. All right. So with the trimmed mean, what does trimmed mean? What does that tell us to do? Trimmed mean. And what section did you learn about that? I'm going to go back. 3.2.
You eliminate the outliners.
Okay, you eliminate the outliers.
Outliners.
Okay, I think it's outliers.
Close.
Outliers. Yeah, pretty close. Okay, so a trimmed mean may be more representative because the outliers, as you said, Luke, are the ones that are very different, right, than the rest of them. So like they would be kind of like the abnormal ones. So yeah, an outlier is a data point that is significantly different from the general trend. And the trimmed mean is better. So how do you calculate the trimmed mean? Well, the regular mean adds all of them up. The trimmed mean takes away any outliers. So 3, 4, 5, 6, 8, and 9 are pretty closely grouped in this example, but 20 is an outlier. So guess what? We just take off 20. Now, if you take off the outlier 20, it does require you to omit an equal number of values on the upper and lower ends of the data set. And I did notice in your last assignment that some of you only took off maybe the one outlier, but you do have to take off, if you take off the 20 here, you see, that means you'd have to take off the smallest one too. Can you see that? Oh, that's a little tough to see, eh? But if you take off one, you have to take off one from each end. Okay? If you take off 2 from the top, then you have to take off 2 from the bottom. So it has to be the same number. So let's go back to our review here, where it says find the trimmed mean. Okay, so the trimmed mean means that we probably should look at seeing if there is a number that is very different than the rest. So what would you say in this list? Is there one that's like really different than the rest?
26 and 5.
Okay, 26 is way bigger than all the rest of them, right? The next highest number is 13, so that's double the next highest number. So if we're going to take off 26, which I would totally agree, that's a good idea, I need to take off the smallest number too, which would be 5?
Yep.
Okay, perfect. So then let's add up all these numbers. So I'm going to add up 10 plus 8 plus 13 plus 9. We're going to skip 5 and 26. We're going to add 12. Oops, and we're going to add 13 and add 13. Do I have to add 13 3 times? Because it's listed 3 times. Do I have to add it 3 times, or can I just add it once?
Yeah, you have to add it 3 times.
I do have to add it 3 times, don't I? Yeah, because they're different measurements. Even though they're the same value, I have to add them all up. Okay. And then I'm going to divide by what? 1, 2, 3, 4, 5, 6. I have 7 here. Do I divide by 7 or do I divide by 9 that I had originally?
Divide by 7.
Very good. You divide by how many numbers you add up. Perfect. Okay, let's do that. Let's do that. Let's do it over here. Okay. I'm going to clear that screen there. So 10 and 8, I can do that in my head. That's 18 plus 13 plus 9 plus 12 plus 13 plus 13. And then I'll let that equal, so that's 78 in total. I'll divide that by 7. So 78 divided by 7 is 11.14. So do I see that as one of my options?
Yep.
Sure do. So 8 is letter D. Awesome. Okay, that's a good one. Any questions about that? Okay. Number 10. I'm going to help you with number 10 here. This is a good question for us to do. It's a bit different. It's asking for the average or the mean cost per cake, but it gives you the cost of cakes and it gives you the number of cakes that are of that price. So this means we would have to, like, there are 7 120s in the list. You see that? And there are 4 $300 cakes in the list, and there are 3 $200 cakes in the list. So that means we actually have 7 plus 3 plus 4 is 14. We actually have 14 cakes here, right? Now the nice thing about this is we don't have to list 120 7 times. We could 120 plus 120 plus 120 plus 120. We don't have to do that. We can do this instead. We can do 7 times 120. You can do that as a product. Then you add to that the 4 cakes that are worth 300. So 4 times 300, right? That's the amount of money for those cakes. And then finally, you can add 3 times 200 because there are 3 $200 cakes. So instead of writing it all out as an addition, you can simplify a bit and write this out as multiplication. So 7 times 120 is, what's that? 7, 8, 40. 4 times 300 is what, 1200? 700 and yeah. And then 600, right? Did I do that in my head? Did I do that right? Okay, so let's add that up. So 840 and 1200 is 2040, and then 600 is 2640. Okay, so that's the total amount of money for all the cakes, and that is per 14 cakes. So the average, the mean cost, the average cost per cake, you do the total amount of money from the cakes divided by 14. So what is that number divided by 14? 188? 188?
Yeah,
188, perfect. 0.57, okay, so is that on here? 188.57? Ooh, look at that, it's right here. And that is correct, that's B. Okay, any questions there? Okay, 11 is just very much like that, so I'll let you guys do that one. Okay, let's see. Another trimmed mean question. We know how to do those. Trimmed mean, okay. Now, if you have to take off more than one off the top or more than one off the bottom, you have to take the same number from the other end, right? So just remember that. Might be tough to tell. Of course, for the past 2 weeks, the trimmed mean. So look at number 13. Do you spy a number that is drastically different than all the rest? What's the lowest or the highest one?
The lowest is 140.
Oh, the lowest is 140. Okay. Yeah, all the other ones are in the 2 and 300s, right? So we probably should axe the 140. That's the lowest number. So what's the highest number? Because I should get rid of that one too. What's the highest number then? 323?
Yeah.
I think you're right. Nice. So if you take those two out and add all the rest of them and then divide by that number. Okay. All right, let's do number 14 together. This is a percentile one. Okay. So a value in the 80th percentile means that, so if you understand what percentile means, this is going to be a descriptor. So what does 80th percentile mean? 80% of the values are lower than the given value. 80% of the values are higher than the given value. The value is 80% of the maximum, or none of the above.
It's lower than the given value.
So which letter is that?
A.
A is correct. Approximately 80% of the values are lower than the given value, if a value is in the 80th percentile. Very good. Because remember, the formula is the number of items below, so the number below, divided by the total number times 100%, or times 100 really. There's really no units required for percentile ranking. You would just say, 80th percentile like this does, see? And so so it's the number below the percentile ranking comes from the number that are beneath that. All right, number 15, another percentile ranking one. Out of 27 students, Stephen had the third highest mark on his essay. What is his percentile ranking? Now you got to be very careful with a question like this. Please don't just look at the numbers and say, oh, 3 divided by 27, that's all I need to do. No, you got to think deeper than that, okay? So remember, this is the third highest mark. So there's a mark that's above Stephen. So here's Stephen. There's one mark that's above him. And then there's another mark that's above him, right? He's the third highest. And then there's a bunch underneath him, right? Okay? So he's the third highest. So we have to take away from a total of 27. I have to take this one away, and I have to take Stephen's mark away to get the number of grades that are less than him. Okay? So how many would be below Stephen's mark?
24.
24? Okay, so this is 27, 26, 25. This is the 24th one, right? So that's 1 to 24. Very good. So so how you calculate this percentile rank is 24. That's how many are below Stephen's mark, divided by a total of 27 times 100. So that's going to be 24 divided by 27 times 100. Now the other thing that I noticed in your assignments there from this last section was that some of you did put decimal places, but you can round to the nearest percent, okay? So round to the nearest whole number. So 88.88, that would be the 89th percentile. Hey. Does that look good? You good with that, Sarah?
Yeah.
Okay, 17 is very much the same as that one. Ooh, 18's a good one. Okay, let's do 18 together because 18 asks us to find one piece of this percentile ranking puzzle here. So we know how to calculate percentile rank. You just do b divided by n times 100. But what happens if we are asked for, what does this one say? Fresh Taste magazine published a ranking of the top 50 restaurants in British Columbia. Looks like 50 is the number, the total number. If Brog's restaurant ranked 94th percentile, so that's this one, so I have the total number and I have his percentile ranking, how many restaurants received a higher ranking from Brog's? Ooh, this is a tough one. This is a very good test question because it really reveals your understanding of this. So we can find how many were below Brog in this formula, right? Because I have percentile ranking and I have the total number, so I can solve for B. But look at B is not what this question is asking for. You have to be very careful here. It says how many restaurants received a higher ranking than Brog. So we're going to find out how many below Brog. Then we have to calculate how many would be above him for this answer. So let's give it a try. So percentile ranking is 94. We don't know what B is. The total number is 50. And then we're going to do times 100. Okay. So I would, two things you could do. You could multiply by 50 first if you want. So 50, that gets rid of the 50 on the bottom down there. So what is 94 times 50? And 4,700. Okay, so 4700. That is 100 times B. So now I need to divide by 100. Okay, so that's going to be 47 is B. Okay, now notice that that's not the answer we're looking for in the question. If 47 are below, okay, watch this. 47 are below, then we have Brog's. He's the 48th one in the row, right? So how many are above him? Yeah. Restaurant number 49 and the top restaurant number 50. So there are 2 above him. The answer to this question is B. Whew. That's a tough one. You have a question? Oh. Okay. All right. Do you guys have any questions about 18? Because that's a perfect question for an exam. I'm telling you, that's got a little bit of everything. Your understanding, got some calculations in there, right? If you know how to do this one, you're gonna ace this exam, I'm sure. Okay. So 19 and 20. Ooh, let's do number 20 together. Let's do number 20, and then the other ones are 4 or 5 other ones. 6 other ones that you guys can do on your own. Let's do number 20 together. So there are 255 scores below the 70th percentile in a sample. How many total scores are there in the sample? Oh, this is great. PR equals B over N times 100. Now, I don't like the little X for times. I don't know. I'm a high school math teacher. I don't like X for times. I use X for a variable. So I'm just going to write like 100 beside there like this, okay, in brackets, okay? It doesn't really matter, but that's the way I'm going to do that. So 255 scores are below. So guess what? B is 255. And the 70th percentile, that's right here, 70 is the PR. So now I'm going to solve for N. I do not know what N is. So I plug in all my values. 70 goes there for PR. 255 goes there for B. N stays as N because I don't know what it is. I'm going to solve for this one. And then times 100. Okay. So there's different ways you could solve this. Okay. You could actually do 255 times 100. You could do that first if you want. Or you could divide everything by 100 first if you want, both sides. So you could do that first if you want. I don't know which one you like better. I'm gonna do the multiplication one. So 70 equals 25500. That's what 255 times 100 is. Okay. And then I'm going to, remember you can cross multiply across an equal sign if you have like a fraction and a number. So this n's going to go up here. I'm going to multiply that by 70, and then it's going to be gone. And then you can divide also by 70. So let's do one step at a time. So 70n equals 25500. And then I'm going to divide by what? To get n by itself, what should I divide by? 70 is correct. So when I do that, the 70s cancel out there. What's 25500 divided by 70? Do you get a number there?
364.
You got 364?
Yeah.
Okay. Let's check that out. 25500 divided by 70 is, okay, yeah, 364. I've got 0.28. So let's see, what about that 0.28? What are we talking about in this question? We're talking about scores. Okay. So 70th percentile. So 364 point something. 0.28. Okay. So looking at this list, obviously the closest one to this number would be 364. Okay? So that's totally fine. If you were doing this, oh, just wait. Yeah, 255 below. He's in the 70th percentile. Total scores in the sample. Yeah. So if you got this number and you're like, oh boy, I don't know if I should do 364 or 365. If you get anything over 364, like this 0.28, you're like, well, maybe you can round it down to 364. Or if you made an argument that, you know what, there's probably 365 things, because you can't have 0.28 of a score, so I have to round that up to the next whole score. I would accept both answers. It looks like they are looking for 364 here. I don't think there's a 365. So I think this answer is 364, but so you can just round your answer.
But even if there was a 364, it wouldn't be this, it can't round up that high, right?
Well, if you were rounding this number, you would round down to 364, yeah. But what I'm saying is that if there were 364 scores in total, but you also had 0.28 of a score, well, how do you do that? You know, like if you had like 5.3 humans, you're like, I have 6 humans, right? Because you can't have 0.3 of a human. You know what I mean? So if you think about it that way, you could always round up, and I would accept that. That would be fine too. But I guess to keep it easy, if you just round your numbers like the way you would normally round, that would be totally fine too. Okay, so this one is B. All right. So you have number 19, number 17 and 16, number 13, 12, 11, 9, 7, 6, and 4 to do on your own. Okay, so you can take the rest of the class and do that, and yeah, try and have that finished for tomorrow.